Hello everyone. Hopefully you are all at home, safe. Good. Today I'll introduce to one of the most vital chapter of your syllabus. That is your optics. Why is it the most vital chapter? Because in this chapter you get maximum questions. That means in your examination, maximum questions will be asked from this chapter. And this chapter is pretty long. So we will discuss various topics of this chapter in different videos. Today, to start with, in this chapter, we will study basically two parts of optics. One is the ray optics and the other one is wave optics. In case of your ray optics, we will study about the reflection, refraction, then we'll study the prism, dispersions of light, glass slabs. In your refraction, we'll study about the glass slab. Then you have the optical instruments, how it works, how we make the arrangement of the various lenses and the optical devices to make it work. That we'll study. And in your wave optics, we'll study about the diffraction, polarization of light, where actually we will see a new dimension of light. That is, light will be treated as a wave. This is a pretty new thing that you're going to study. But we'll start with your ray optics. In ray optics, many of the part of this ray optics you have already studied in your class 10. But we will study all those phenomena are there along with some more, but in a more elaborated way. The definitions will come up in more elaborated, in more specific, in more minute way. So to start with, reflection of light. Now, what do you mean by reflection of light? Earlier, what you have studied? Whenever a light falls on a medium, and if it bounces back, we call it as reflection in general term. Now, today, how we will specifically or more minutely, more accurately explain the reflection of light. Let's try to define it. Say, light traveling in one medium when falls on a second medium. A portion of the incident light, depending on the nature of the surface of the second medium, is turned back into first medium. This phenomena is known as reflection of light. Now see, a reflection of light can be of two forms. One is your regular reflection. Other one is diffused reflection. Now, to explain about the regular and diffused, what it is. Suppose if the surface or the reflecting surface is pretty shiny, as you can see in case of mirrors. I have a mirror, I'll just show you. Suppose this is the surface. See, it's very much shiny. If I just focus towards the light at my room, see, it is pretty shiny. You can see your image and all. Right. So this type of reflection is called a regular reflection. Means if I put an object in front of it, I can see a clear image of this object. So this is your regular reflection. But say about the diffused reflection. Say for example, if I take a piece of paper, let me take a piece of paper. See, in this piece of paper, light is falling on this piece of paper. Suppose I'm taking a source of light, I'm taking a torch and I'm putting a source of light on it. You'll find, say I'm putting it over here. So here, in this source of light, you cannot see your own image. Rather, the whole of this light is getting diffused. So when this is the white surface on which when light falls, it is actually spreading apart. This type of reflection is called diffused reflection. Now, why this diffuse reflection is actually, why this sort of reflection is called a diffuse reflection, and why it happens. If you minutely study, you will see that in case of regular reflection, the surface is pretty smooth, very even. And in case of diffuse reflection, the surface is a bit rough. Even though in case of piece of paper, we see it's pretty plain, fine surface. But actually it is not so. If we see it on a microscope, we'll see that it has a very tiny pores. So what happens actually in those uneven surfaces, when light falls on it, it reflects back in different angle and in different ways. So we do not get an image that we are expecting to in case of a reflection. Clear? Now we'll go ahead, before we go ahead with the laws of reflection, let's see how it actually works, and we'll also I'll also explain you the law of reflection with a diagram. Let's move to this diagram. Let us try to understand the laws of reflection using this diagram. See, let us consider this xy to be the plane mirror's surface and n be the normal. Now, if this ray A, this is the incident ray, that means the light is coming and falling on the surface of the mirror, and after reflection, it is bouncing back to the same surface along this path, along this line, say B. So this is my incident ray, this is my incident ray, and this is my reflected ray. Definitely this is my normal. So what happens actually, the angle which this incident ray makes up with the normal, this is known as angle of incidence. This is known as angle of incidence, and the angle that is made by the reflected ray with the normal is called the angle of reflection. Angle of reflection. Clear? Now, what does this laws of reflection says? The first law of reflection says that the incident ray, the reflected ray, normal at a point of incidence on the reflecting surface, all lie on a same plane. Correct? The second one is quite important. It says the angle of incidence, this I, is always equal to the angle of reflection. Clear? Now, let us try to see whether this sort of thing, what we have drawn diagrammatically, this actually happens or not. Let us try to frame up an experiment like this. I'm taking this mirror and placing it over here. Okay, as it is given over here. And I'm trying to put up a black color board over here so that we can see the source of light. Now see, suppose I'm taking a torch and I'm just putting a light on this mirror just to check whether this sort of reflection occurs or not. See, I'm just putting this source of light on the mirror, but I'm getting a reflection over here. See, this is the reflection of the source of light. See, if I'm putting it directly, it looks like this. Now, if I'm putting on the mirror, it is reflected back at this particular thing. So, if we draw a normal like this, so the angle formed between the incident ray and the ray which is coming to after hitting this mirror and hitting this surface, this is the reflected ray. So the angle between the incident ray and the normal is the angle of incidence, and the angle between the reflected ray and the normal is the angle of reflection. Incidence. Clear? Now, coming down to some more aspects, and one more important thing is about this diffused and regular reflection. That the regular reflection always obeys the law of reflection, whereas the irregular or the diffuse reflection do not follow the raw law of reflection. That is the why you cannot see the image. Now, when we are saying about the image, there are two types of images. One is real, other one is virtual. Now, what is real image and what is virtual image? The image that we can obtain on a screen is called the real image. But those images which we cannot obtain on a screen, but we imagine that if it would have been formed on a screen, it would have been at that place. So this sort of images is called the virtual image, which is not actually forming on a screen, but it appears to form. That's a virtual image. Now, to start with your plane mirror, or rather, we'll start with the mirror, of course. A smooth, highly polished surface that is capable of reflecting maximum amount of light of incident upon it is called the mirror. This we have already studied earlier. And in here we'll study two types of mirror. One is plane, other one is spherical or parabolic. That is depending upon the shape of its reflecting surfaces. To start with your plane mirror, let us see certain characteristics of plane mirror. First is the image, whatever it is formed in a plane mirror is erect, it is virtual. Now how it is erect? Let's see if it is erect or not. Suppose if I am taking this mirror and I am trying to take up an object like this and I am putting it in front of it. See, this is this if I am putting, see, I am getting a straight image. It's not getting inverted. It's not getting inverted. So it's a completely straight image I am getting. So this is erect image. So in case of plane mirror, we get erect image, virtual image. The size of the image is equal to the size of the object. It's almost it's equal. See, if I'm putting it on this top of this, the object and the image, they're of equal size. The image is formed as far behind the mirror as the object is in front of it. Actually, the image forms far behind the mirror. That is the reason why we call it that the image is virtual. One most important thing is the image is laterally inverted. Now, what do you mean by this laterally inverted? See, here I've written I and R. If I just try to focus this I and R, see how it looks. It looks inverted. Alright, it looks inverted. So similarly, if we write, this is the reason, of course, you have studied earlier that why in case in ambulances, in front of the ambulances, the word ambulance is written in mirror image format, so that the car which is traveling in front of the ambulance can see the word ambulance clearly and in a proper way through his looking glass. Got it? So this is again a very important thing. We see a lateral image. That means, or a mirror image. We can see a lateral inversion. We can see a mirror image. How we can see a mirror image? Let me draw and show you. Suppose if this is the mirror, so in this side of mirror, if I write the alphabet B, on the other side of the mirror, we'll see it like this. See, if we try to do this experimentally, we can see it. See, if I see the B over here, see, it looks like this, as I've drawn over here. Now, if I do this the same way on the other side, the reverse one, I'm seeing it clear. So this is the lateral inversion. The left hand side turns up to the right hand side. This type of inversion is happening. This is called the lateral inversion. Clear about it? Let's start another topic over here regarding this plane mirror. Now let us see the effect of rotation of a plane mirror on the reflected ray. Now, for a given incident ray, if a mirror is rotated through an angle theta, the reflected ray rotates through double the angle. That is, it will become 2 theta. And the mirror here should be rotated about an axis which is not normal at the point of incidence. But if the mirror is rotated about an axis which is normal at the point of incidence, then there will be no rotation of reflected rays. That means here we can say that if the mirror is rotated through an angle of theta, that means if I take this mirror and if I rotate it at an angle of theta, the reflected ray, that means if this is the mirror, if I am rotating at an angle of theta, the reflected ray rotates through an angle 2 theta. So this reflected ray, that will be moving at an angle of 2 theta. Clear? And then we'll move towards certain and another very important topic about this particular portion of your plane mirror, that is multiple image formation by two mirrors inclined at a particular angle. Why I am saying this important? Because on this particular topic you will be getting numericals also. Okay, so let's see what we can study in this part. So here it says that when an object is kept between two mirrors inclined at an angle theta, then the number of images are formed due to multiple reflections, and the number of images formed is given as 2 pi. The number of images is given as 2 pi by theta minus 1. This is the formula by which we can find out the number of images. Let us do it in a separate sheet of paper, and I'll also show you this particular multiple image formation through an experiment. Let us see how the multiple image formation by the two plane mirrors inclined at an angle is done. So when an object is kept between two mirrors inclined at an angle, say for example, I've taken two mirrors. See, if I'm taking this two mirrors and then I'm inclining at a particular angle and I'm putting an object in front of it, I'm getting multiple images. See, you're getting multiple images of my finger in front of the mirror. Got it? So that means when an object is kept between two mirrors inclined at an angle theta, a number of images formed due to multiple reflection, and the number of images formed is given as 2 pi by theta minus 1. So suppose let the angle between two mirrors be 90 degree. So therefore 2 pi by theta minus 1 will become 2 pi by 90 minus 1. So that is equal to 4 minus 1 is equal to 3. So you are getting 3 images if you are taking 90 degree as an angle between the two mirrors. So let us see if this thing actually happens or not. Let us first try to frame up a 90 degree angle so that we can place the mirror on it. Let's draw a 90 degree, approximately 90 degree angle like this, and let us place the mirror on this so that it becomes almost accurately 90 degree. Okay. And now I'll be placing an object in front of it and will try to see the image formed by these two mirrors kept at an angle of 90 degree. I'm just putting up an image object over here, and I'm just turning my camera's angle so that I can show you the formation of images. See, on changing this angle, see, I've put up this mirror in a 90 degree and I put up an object like this in front of the mirror. See how many images you can see. I'm just turning up the camera so that you can see the images. See here, you'll see that this is the object and 1 image, 2 image, 3 image. So we are getting 3 image of this object when the mirror is kept at an angle of 90 degree. So this we have proved practically. See, I'm just turning this angle at various other movements. We are seeing the same thing over here. Another important thing about the plane mirror, that is the speed of the image due to the relative motion of object and mirror. So the mirror, first of all, we say that the mirror remaining fixed. If we place the mirror, keep the mirror fixed, and if the object is moves relative to the mirror with a speed of v, that means this object is moving with a speed of v, then the image also moves with the same speed v relative to the mirror. So if I am moving this object towards the mirror, the speed of the movement of the image is also same. But if the object is remain fixed and we move the mirror towards this object with a speed v, then the image moves with a speed of 2v, that is the double the speed of the movement of the mirror. This is very important relation you should remember for answering your MCQ type questions. Let us discuss another topic before we move to certain numericals on plane mirror. That is the size of the mirror for image formation. So what should be the minimum size of the mirror required to get a full image? Let's try to find out that. Now let us draw a diagram to see what is the minimum requirement of mirror for a full size image. So let us draw a straight line. Let us put the mirror over here, object over here. So definitely if object is over here, from this distance will be same as for the formation of the image, since it is of same size. So let this be the mirror and let this be an object. Now we know that in case of plane mirror, we get the object of same size. So definitely we'll get the object somewhere over here. So that is of same height. Clear? So if this is my object, so this will be my image at a equal distance of equal size. Now we would like to see that if a person is standing, this is the person, so this is the man who is standing in front of a plane mirror and he wants to see his full image. So how much or what will be the size of the mirror required to see the full size of that particular person? The person can see his full size in that mirror. So geometrically we can prove it. Let's see. Let us join these 2 points, the head of the person to the image head, by a dotted line, and what we get is a rectangle. Now the person is seeing from this part. Here is the person's eye through which he is seeing, and here is the person's toe. So now when he will be seeing his image, so he will be seeing his image in this way diagonally. From here he is going to see his image. This is the full image of the person. This is the head, this is the foot of that person. So what we see that if we just cross this diagonal or we intersect this diagonal, this intersects just half the way of the person's or the object height. That means this much size is only required. So if the height of the person is x meter, so the mirror that is required to see the image will be x by 2, or rather half the size of the object. That is the minimum size of the mirror required to see a full image of man. Clear? And the minimum size of a mirror, that is if it is fixed on a wall of a room and in which an observer at the center of the room, then it can see the full image of the wall behind him and 1/3 of the size of that wall. Clear? Let's move towards the numericals. Certain numericals. Let us see some numericals to understand these topics or the multiple image formations more clearly. Let us discuss certain numericals. Let's see this numerical. It says, the question says that two plane mirrors A and B are inclined to one another at an angle theta. A ray of light parallel to B is incident on A, and after one reflection from A and one from B, the reflected ray is found to be parallel to A. We have to find out the angle theta. That means we have to find out the angle between the two mirrors. So let us try to draw the figure. Let this be my mirror A, and let this be my mirror B, at an inclined at an angle theta as given. Now an incident ray, it's given a ray of light parallel to B. That means a ray of light parallel to B is hitting over here. So let this be the normal drawn. So definitely it is going to hit back at the same angle to the other mirror. From there it says that after reflection from A and one from B, the reflected ray is found to be parallel to A. That means from A, after reflecting from this mirror A, it is going back parallel to A. So this will be my normal drawn over here, 90 degree. So therefore, if this is theta, let us name this figure. O, let it be O. Let this be point F. Let this be point E. Let us point this one be normal N1 and let this be normal N2. And finally, the final reflection, let us name as G and H. So the ray is coming this side. After hitting, it is going this, and then it is going this way. So, and this is the mirror A, and this is the mirror B. Now see, since EF is parallel to OB, so therefore this angle is equal to theta, corresponding angle if this is an intercept. So if this angle is theta, then on the other side this angle will also become theta, because angle of incidence and angle of reflection is equal along with the normal. So the other side also becomes equal. So if this angle is theta, then this angle also becomes theta. Similarly, when GH, this line is parallel to OA, so therefore this angle becomes theta, corresponding angle to this. Now if this is theta, therefore this angle also becomes theta, because this angle of incidence, angle of reflection is equal. Clear? So in this triangle we get theta, theta, all these three angles are equal. So therefore theta plus theta plus theta will get 180 degree, and therefore this theta will be nothing but equal to 60 degree. Let us try to write this. How will you write it in your examination? So here we'll write that from the figure we see that EF is parallel to OB. So therefore we can write angle EFA, that is equal to angle GOF, that is equal to theta. Again, your the ray EF is reflected on F. So here what we see that again as the ray EF is reflected at F. So angle GFO, so angle GFO, that will be equal to angle GOF is equal to theta. Also, GH is parallel to OA and GH is reflected at G. So angle BGH, that will be equal to angle FGO will be equal to angle GOF is equal to theta, this one. So therefore sum of three angles of triangle GOF will be equal to theta plus theta plus theta is equal to 180 degree. Therefore 3 theta is equal to 180 degree, or we can write theta is equal to 60 degree. So here we get the answer as 60 degree. Let us move to another problem. Let us see this example. Two light sources S1 and S2 are at a distance of 105 centimeter from each other. Two plane mirrors, one at 60 centimeter from source S1 and the other at 37.5 centimeter from source S2, are so arranged that the images of the sources coincide. Find the angle between the mirrors. So let us try to solve the draw the diagram. So let this be source S1 and let this be source S2. So, and let the distance between these two sources as given in your question is 105 centimeter. Now it is said that two plane mirrors, one at 60 centimeter from source S1. From this source S1, light is traveling in this way. A mirror is placed around at 60 centimeters. So let this be let us draw the ray like this, and definitely the mirror will be placed in this way. So if this is 60 centimeter from the source, the mirror is placed. Another mirror, it is said that it is placed at 37.5 centimeter. So let it be this distance. So definitely the mirror will be placed in this way. So its reflection now. So This is 37.5 centimeter. It says that it is so arranged that the images of the sources coincide. Now, in case of plane mirror, we know that the image forms on the other side of the mirror. So, definitely at a same distance. So, therefore, if this is 60 centimeter, that means another 60 centimeter, or let us extend this thing and let us extend this thing also at the back side. So, they are coinciding. So, this distance is again 37.5 centimeter. And this will be 60 centimeter. This is coinciding over here. So let us name this as S. Now, and let us point of intersection of these two mirrors be O. This mirror be let M1 and this be M2. Now, what we have to find out is find the angle between the mirrors. That means this angle we have to find out. That is theta. Now we see that this SM1OM2 is a cyclic quadrilateral because the sum of the opposite vertices is 180 degree. Therefore, the sum of the other vertices should also be 180 degree. Therefore, this angle becomes pi minus theta. Now, in triangle, so what we can see that what we'll write is that from figure, it is evident, it is clear that M1O M2S is a cyclic quadrilateral, and hence if theta be the angle between the mirrors, then angle S1, S2, this is equal to pi minus theta, what we have written over here. So, from triangle S1, S2, we have cos pi minus theta will be equal to how much? This angle, cos of this angle will be equal to square of the sum of this side plus square of the sum of this side minus square of the sum of this square of this side divided by twice of this side plus into this side. So that is equal to 120 square plus 75 square minus 105 square divided by 2 into 120 into 75. Now, how did you get this? Let us recall small thing about from your trigonometry, which says that if there is a triangle which is not a right angled triangle, if let it be A and let this be B and let this be C, and if the sides are A, B and C, and this angle be angle B, angle A and angle C, then it is said that A square is equal to B square plus C square minus 2BC cos theta, and your B square is equal to A square plus C square minus 2AC, it will be cos A angle, since it's A square cos A, and here it will be cos B, and C square is equal to C square, this C square, this length will be equal to A square plus B square minus 2AB cos of C. So from here what we can find out, cos of A, cos of B and cos of C. So cos of A will be equal to, from this we can write B square plus C square minus A square divided by 2BC. Cos of B is written as A square plus C square minus B square divided by 2AC, and cos of C is written as A square plus B square minus C square divided by 2AB. From this relation only we have written this, cos pi minus theta is equal to this side, square of this side, that is 120 centimeter, plus square of this side, that is equal to 75 centimeter, minus square of this side, that is 105 square, divided by twice of this and this. So see this thing, if this is an angle B, so we are getting A square plus C square minus B square divided by 2AC. So this is how we get it. From here, if we calculate, we get it as 9,000 divided by 18,000, that is equal to 1 by 2. And we also know that cos pi minus theta is equal to minus cos theta. So therefore, cos theta will be equal to minus 1 by 2. Therefore, theta will be equal to 120 degree. So here we get the angle between the two mirrors is 120 degree. Clear? So I hope that you have understood reflection and plane mirror, various effects, various multiple images formations, numericals. So in my next video I'll come up with spherical mirrors. Till then, be at home, be safe.